Hello class, I'm working out of your Algebra 2 book 8.1, Function of Operations. We are looking at function compositions in the first section to start. There are properties of function compositions. For instance, f plus g of x is equal to separating out f of x plus g of x as given. In the same way, f minus g of x equals f of x minus g of x as given. F times g of x is equal to f of x times g of x as given. And f divided by g of x is equal to f of x over g of x, where g of x cannot be 0 because a fraction with a 0 in the denominator is undefined. Our first example, you're asked to write the function rule for each expression. We have a function of x equals x plus 1 squared and a function g of x equal to x minus 2. So if you're asked to work the properties that these show that we just worked on the prior slide for each operation, we're going to say, okay, the first one will be f plus g of x equals x plus 1 squared plus x minus 2. Where did this come from? This is f of x added to g of x. If you're asked to evaluate these, then we are actually solving or simplifying. So x plus 1 to the second power outside the parentheses is x plus 1 times x plus 1, all plus x minus 2. If we work this out, we're going to have x times x squared. 1 times x plus 1 times x, which is 2x. 1 times 1 plus 1 plus x minus 2, like terms emerge. So we have x squared, we've addressed this one, 2x plus 3x, we've addressed these, 1 minus 2 minus 1. Alright, so we have x squared plus 3x minus 1 is our final expression or function. So if we're asked to write the function rule, then we go back and we would say our function rule is this rule for this composition of functions. Alright, if we are asked to subtract them, and we say we still are working with the f of x, g of x that was given above, we're going to have f minus g of x, which is equal to x plus 1 all squared, minus x minus 2. So remember, this was f of x, and we're subtracting g of x. It's like substitution. Got a couple things going on here. We have x plus 1 times x plus 1 minus x minus the negative 2. So it's sort of like an invisible 1 here, multiplying in distributive property, flipping the signs of everything inside the parentheses we're going to have a negative x plus 2 hanging out here. Again, we're going to factor our squared terms, and that will work out to be x times x is x squared. 1x plus 1x is a plus 2x. 1 times 1 is a plus 1 minus x plus 2. Like terms emerge, and we'll have x squared, that's addressed. We have 2x minus x, so that's a positive x, that's addressed, and 1 plus 2 plus 3 is our final expression here. If we are to write the property or the function rule for each, we would grab this one for that example. Alright, in another example for the multiplication operation f times g of x, we're going to have x plus 1 all squared times x minus 2. It's going to look like this: x plus 1 times x plus 1 times x minus 2. So in associative property, we can start factoring everything out and start to multiply it back to a final simplified expression. So we've got what we have worked already. We're going to have x squared plus x plus 2x. 1 times 1 is plus 1, all times x minus 2. So what we have now is x squared will be multiplied by x minus 2, plus 2x will be multiplied by x minus 2, plus 1 will be multiplied by x minus 2. Distribute. We have x to the third power here, minus 2x squared, plus 2x times x is 2x to the second power. 2x times negative 2 is a negative 4x, plus x minus 2. Consider like terms. X cubed is hanging out by itself. We have a negative 2x squared plus 2x squared. That's completely going to drop out. We have a negative 4x plus x. That's a negative 3x minus 2. And we would go back and write the function rule from the original property. Alright, if we're asked to divide, we're going to have f divided by g, all of x, which equals x plus 1 squared, all over x minus 2. We can't really solve this. We would end up not being able to simplify it very well, because it would be x plus 1 times x plus 1 on top, and we couldn't cross cancel anything. So all we can say here is x cannot be equal to 2, because that would be 2 minus 2 is a 0 in the denominator. So we address that we can have a 0 in the denominator. And this is our final solution. We would go back and grab our property for that from here to write the function rule when addressed in our instructions. Okay, another example. Example 2. Evaluate when f of x equals x squared minus 3 and g of x equals 2x plus 1. Alright, f composition g of negative 2. Okay, so what we're going to do here is a lot of substitution. And if we have a composition of g of -2 for f, we're going to grab that g of -2 first, which means in the g function expression, everywhere we see a x, we're going to pop in -2 for that. And that, very simply put, is a -4 plus 1, -3. Now, since we have a composition to work with, we're going to have the composition of f g when it's -2 equal to, well, to rename this part, when g is -2, the answer is -3. So all of this is -3 here. And we're going to pull that expression for the f of x function that we're given. And we're going to plug in a -3 everywhere we see x. Okay, so that's going to equal -3 times -3, which is a positive 9 minus 3, which goes to 6. All right, if we have f of g of 3, we're going to say g of 3 equals 2 times 3 plus 1, which will equal 7. Okay, that's from the original given expression. We plugged in a 3 everywhere we saw an x in the g of x function. So we just get 7 there from what we were originally given. Okay, so now we're going to say f g of 3 equals f of 7, because this 7 renames g of 3. So we're just plugging it in right here. That's where it comes from. We solved for it already. Okay, so in the function of f right here, we're going to plug a 7 in everywhere we see an x. We're going to have 7 squared minus 3, which equals 49 minus 3, which equals 6. Excuse me, 46. Okay, 49 minus 3 is 46. All right, C, for an example, flip it around and say g of f of 3. We're going to go back to our original given function expressions. They are right here. These are what I'm drawing from, the original ones given to us. And we're going to pull the f of 3 first. We're going to figure out what that is. And that will be 3 squared minus 3. Well, that's 9 minus 3. That's 6. Okay, so now we're going to have f of 3 equals 6. Well, g f of 3 equals g of 6 in substitution. And we're going to pull from our original expression given 2 times 6 plus 1. Plugging in a 6 everywhere there is an x. And we're going to have 12 plus 1 equals 13. All right, in example 3, we're asked to write a single function rule representing each composite function when the functions are f of x equals x squared minus 3, g of x equals 2x plus 1. All right, so if we have f composition g of x, then that's going to equal f g of x, which equals f of 2x plus 1. So we literally plug the g of x function in numerically from our expression. So we have a substitution. Alright, so now everywhere we see an x in our function of x, we are going to plug in 2x plus 1. So if that is true, then this is going to equal 2x plus 1 for x right here, and that's squared, all minus 3. So I just plugged in 2x plus 1 everywhere I saw an x. That's a squared term. Gotta deal with that. Okay. So if that's squared, then this is going to equal 2x plus 1 times 2x plus 1, all minus 3. Okay. 2x times 2x is a 4x squared. 1 times 2x is 2x plus 2x. 1 times 2x is another plus 2x. And 1 times 1 is a plus 1, all minus 3. So now, I'm going to come over here for the sake of room. 4x squared plus 4x minus 2 is our final evaluation or simplified answer. Okay, another example from the same given functions. We switch it around. Example B, g of f of x. That's what we're looking at. Hey, that's going to equal g f of x, which equals g x squared minus 3 as given for the f of x, which equals in the g 2, and then x is x squared minus 3 multiplied by that 2 plus 1. So everywhere we see an x in the g function, we are plugging in the f for the x. So the f expression is going to fit in there. Okay, then we start evaluating 2 times x squared. Got that. 2 times negative 3, negative 6. And that's plus 1. So simplified, that's 2x squared minus 5. I hope this helps for examples. Please go through examples 4 and 5 in your pre-reading as well. And I will see you soon.